So we talked about the term thermodynamically favored. Now, thermodynamically favored reactions occur without any input, but non-thermodynamically favored reactions require input from the surroundings. So then how can we tell if a reaction is thermodynamically favored? So exothermic reactions are typically favorable. We're not saying they always occur, but they're more often than not favored. And reactions that produce a greater degree of disorder are also generally favorable. Not saying they're always the ones to occur, but generally they're more favorable. But we need more than just a generally favorable. We need a yes or no answer. We've got to learn the conditions that have to be set in order to make a reaction thermodynamically favored or non-thermodynamically favored. There's two methods. The first one we're going to look at is the entropy of the universe. Let's visualize again what we mean by the universe. So the universe involves the surroundings, that means everything around you, and then the system. So this is the reaction that is taking place. And parts of the surroundings, the beaker that this is in is going to be the surroundings. The water that this reaction might be taking place in is part of the surroundings. The only thing that is considered the system is the reaction. So for example, if this was the reaction that was taking place, this would be the only thing that's the system. All of these are aqueous, so all of them would take place in the water, but the water would be part of the surroundings. So if we're trying to figure out if a reaction would occur, we have to look at both the surroundings and the system, both of which fall under the category of the universe. And remember, the entropy of the universe is always increasing. The entropy of the universe, the change in entropy for the universe, is going to be the entropy of the system plus the entropy of the surroundings. If the change in entropy for the universe is greater than 0, so if this number comes out to be positive, then the reaction is thermodynamically favored. If the entropy of the system plus the entropy of the surroundings was a negative number, so less than 0, the reaction would not occur without other intervention, in which case that would change the delta S of your surroundings, making it so the entropy is positive again. Basically what this is saying is, once more, nature is moving towards disorder. So in order for something to become organized, something else has to become disorganized. So when you take a pile of blocks and you stack them, you are creating a system that is more organized, but your surrounding, which is you, are creating a state of disorder within yourself because you're expelling energy, you're burning some of your body's fuels, calories, so that is increasing your disorder. And so overall, you would wind up with a positive number. So if we wanted to make the connection between enthalpy and entropy, for an exothermic reaction, you're releasing heat, and that heat, that's going to increase the disorder of the surroundings. So that energy that comes out is going to increase the disorder of the things surrounding the system. With an endothermic reaction, it's taking energy in from the surroundings, which is going to decrease the disorder of the surroundings. But this reaction can occur if that energy that's put into the system increases its disorder more than it decreases the disorder of the outside, thus maintaining the increase in entropy for the universe as positive. So one process that we can guarantee to be thermodynamically favored without really having to do any calculations is one that increases the entropy of the system. So if we think of a reaction that's going to generate more gas or more molecules or go from a liquid to a gas, that would be an increase in entropy for the system, so a positive number there. And if the reaction is exothermic, that's going to also increase the entropy of the surroundings. So we would have two positive numbers. Two positive numbers is always going to equal a positive change in entropy for the universe. So those aren't the only thermodynamically favored conditions, but those are the easiest ones to identify.